So first of all, thanks for coming to our talk. And so we'll talk about OpenEdX deployment made easy with Grove. So I'm Geoffrey Leahy from senior open source software developer working at OpenCraft since 3 years, and I'm from Sweden.
Hi everyone, thank you for coming. My name is Kaustav Banerjee. I am a senior open source software engineer working at OpenCraft for the last 6 months, and I'm from India. Briefly about OpenCraft. OpenCraft is a fully remote company contributing to OpenEdX since 2013. We are a flat company spread across all the continents in the world. We at OpenCraft love open source. So even our handbook, which defines how our company is, that is also open source. And every work that we do, that we contribute everything back to open source. At least we try to do most of it. We'll talk about we'll talk about how we do deployments now and what we are trying to do.
Yeah, so just before, you can check the slides if you want. I wrote it here, and so, yeah, anyway. So, yeah, before we can talk a bit about Grove, we need to talk about the different kind of OpenEdX deployments. And the first of all will be development deployment. So what do we have now? Most of us are probably using the DevStack, which has been provided by OpenEdX and maintained by the community since many times. So I will talk about what's good with the DevStack. So the DevStack is Docker-based and run through Docker Compose, which is fine and convenient. Everybody know how to use it. So that's a good point. It's also well-maintained in the community projects, and we are still getting nice improvements over the time, like having multiple OpenEdX versions installed on your machine. So that's a good point about the DevStack. But what is not that good? Actually, having multiple versions of OpenEdX is not working very well. I mean, you can't have these different versions running at the same time, and some data will be shared between these installed versions. So that's an issue. Also, if you need to update your DevStack, you will probably face some issue. Like updating your DevStack is not always straightforward, and you may need to rebuild it like from scratch a lot of times. So we all know this kind of issue, and this is like a huge pain in the DevStack. So, and this is probably because this is a very complex. The DevStack is kind of complex. It's taking a lot of time to build. Also because the Docker image layers are quite huge, so a lot of data are required to be downloaded. So it's taking a lot of time. And if it fails, you need to run everything. But there is a lot of documentation and stuff that you can find on the forum, but it's not easy to deal with it. So that's some issue with the DevStack right now. So what could be better? Actually, the multiple version of OpenEdX could be better handled, and also having a great isolation of data between the DevStack could be better. Like I say, having thinner Docker layers could be better. So the build will be faster and everything. So everything is linked, and we all kind of know this kind of issue with the current DevStack. Also, having a more similar development and production environment could be nice, because we would be able to spot issues earlier in the process and be like more familiar with the production deployments also. So that would be great to have something closer between these two deployments. So what's the future of DevStack? You may already know what's the future because it's already here, but using more modern technology like Kubernetes, being project built and maintained by the community, and having like an official way to deploy OpenEdX. So you might think we already have this thing, which is true. We'll talk about it a bit later. So this was the development deployment. We need to talk a bit about production deployment. And to talk about that, I will talk about how we are dealing with this kind of deployment at OpenCraft. At OpenCraft, we are using OSIM, which stands for OpenCraft Instance Manager. This is an open source project that you can find on GitHub and also at osim.opencraft.com. So you can already check it, use it, and giving us any feedback, anything you want. So it's open source, feel free to use it. we are using to do multiple instance deployment and management at scale. So each of our clients have a unique deployment on OSIM. And so basically, it's an open source, it's a Django project that's handling all the things around deployment, running Ansible scripts, and like dealing with DNS entries, load balancer, monitoring stuff, and everything you will need for production deployments. You can also deploy MFEs, by the way. But everything is deployed on OpenStack. But what are the issues we are facing with these current deployments? Actually, the deployments are very long. It's about 2 to 3 hours, something like that. This is an issue right now, because of that, it's not very fault tolerant, which means if one deployment is failing, we need to wait for a new one to come to replace this one. We can kind of handle this issue with blue-green deployment, but everything has to be done manually, like adding a new server on the load balancer, testing it, etc., stuff like that. You may know this kind of thing. So it's not fault tolerant, it's not very scalable. We can handle like kind of huge deployment, but it's not like auto-scalable and everything, stuff like that. So this is an issue we are facing right now. Another big issue is mass patches and mass updates deployment over all of our client instances. This is difficult to handle. Most of the time we need to do that manually or by batches, but it's not very fancy to do. This is most of the time an issue, and sometimes we are receiving like patches which are not deployed, released on the repository, so we need to deal with this thing manually and apply patches on the server and everything. So this is a big pain today we are facing. Also, we don't have rollback supports. Rollback today is like redeploying something with an older version and adding back to the load balancer. So we can do that, but this is not very fancy. So what we have now is Tutor. So Tutor is, what is great with Tutor is that, first of all, this is a community and an open source project. And you can do both local, so development deployment and production deployments. It's running on Kubernetes, it's very documented. This is now the official way to deploy OpenEDX. And so we should all start using it instead of the DevStack, actually. So the next time you are trying to update your DevStack and everything is failing, it's a good time to start using Tutor. There is no more excuses. So probably most of you already know about Terraform and Kubernetes, but since this is two new tools in OpenEDX environment, I will just briefly talk about these tools. So Terraform is basically infrastructure as code. This is an open source tool developed by the famous company HashiCorp. This is super pluggable, written in Go. So basically, if you need to remember one thing about Terraform, it's building, changing, and version controlling your infrastructure. It supports multiple cloud providers and everything. So also Kubernetes is an applications and container orchestrator. It's about deployment, rollback, auto-scaling, monitoring, load balancing, everything you need for your infrastructure. The good thing also about Kubernetes, which is also an advantage of Terraform, is that everything is done in a declarative way. So this is the future of infrastructure management. So now let's talk about Grove.
Yeah, so Grove is basically it's a combination of all the good things that we talked about right now. So it is an open source project from OpenCraft, which is hosted in GitLab. So the concept behind Grove is to have a super stable production ready experience for deploying and managing multiple OpenEDX instances parallelly, and to deploy and manage the infrastructure required for those instances in a same package. So for infrastructure, we of course use Terraform. Using Terraform makes any infrastructure changes super predictable, and there can be peer reviewed for any changes. Currently, with Grove, we support AWS and DigitalOcean, but as you will see, adding support for new cloud providers is very easy. The core portion of Grove is not dependent on any cloud provider. Grove is meant for multiple instance deployments. It does so using Kubernetes. So the good thing about Grove is that each instance in a cluster can be heavily customized individually or en masse. Customizations could include themes or configurations or translations, whatever. And it supports mass deployment of patches and even mass upgrade of the OpenEDX release. And it is just one click. You just send a request and all the instances will be upgraded at a time. So that's good. And Grove does this using Gitlab CI. So everything is tied together in Gitlab CI. We use what is called Gitlab triggers. So every action can be done using post requests. So when a post request comes into Grove, it generates a pipeline, CI pipeline, dynamically based on what the request is. And it also, we have also added support for CLI. So you don't even need to, you just need to install Docker, and you need to have the code base, and you can do almost all the management stuff from your local desktop. So how to use Grove, and what exactly is Grove? So basically, Grove consists of two repositories. One of them is Grove repository, that forms the core part of Grove. It contains all the Terraform and Python and GitLab CI scripts. The core scripts, as I said before, is independent of all of cloud providers. So if we need to add more cloud providers, we just need to add the corresponding Terraform scripts, and it just works. The Grove template repository is intended to be forked by anyone who wants to use Grove. And it is meant to be a private repository because it will hold all the secrets for your clusters and all the configurations and customizations for your instances. So if you want to start using Grove, you just need to create a fork, a private fork. First, you need to create a group actually in GitLab and create deploy tokens there. And then you need to create a private fork of Grove template. So each private fork of a Grove template represents a Kubernetes cluster and all infrastructure resources which are associated with it, such as the S3 buckets, the RDS instances, etc. So each private fork has its own Terraform state in GitLab. So the state is saved and managed in GitLab. So even if you are doing some deployment or management, whatever, from your local desktop, it will still use that state from GitLab, so you can do it from anywhere. It just uses one state. And of course, you need to set up all the cloud provider credentials, so like AWS access keys, etc. So that is all you need to do to set up Grove. Just create a fork, add the credentials, and that's it, and just add the tokens. Now to trigger a deployment, what you just need to do a post request. That's all. So first of all, Grove uses what is called GitLab triggers, pipeline trigger. So you need to create a trigger token, and each private fork will have a project ID. So you just need those two things. You need to add the token and the project ID there, and just do this curl request, post request. So this sample request is for just a default deployment. If you want more customizations, for instance, you just need to add more variables here, and you can just do customizations from using the request. So once you do this post request, okay. So as I said, the Grove template, the private fork of the Grove template represents one Kubernetes cluster. Inside the cluster, there we can have multiple instances. Now each of the instances is represented by this. So there's an instances directory. So whenever you create a new instance, we'll just have a subdirectory for that instance with its name. And the subdirectory just holds all the configurations and customizations for that instance. So we have a defaults directory which will have all the default configurations. So suppose you need to have some customization which is common for all your instances, you can do there, and it will get copied. Or if there is some specific instance-related configuration customization, you just add it to the post request, and the default gets overridden, and a new configuration is created. So the pipelines. This is what Grove does when you add a post request. So it will create it will generate the pipeline dynamically whenever you add a post request. So post request could be, the deployment request could be multiple types. You could create a new instance in your cluster. You could make changes to the existing instance, or you could do mass deployments. So these are few of the different types of deployment requests which you can do. So based on that, the pipeline steps will change based on the type of request that you've done. So this pipeline is always generated dynamically. So the example shown here is for a deployment of a new instance. So here you can see we have Grove creates, first runs Terraform, and it will, for instance specific things like creating a Kubernetes namespace and creating DB users. Those things are done here for Terraform. It will then build all the images, Docker images for the instance, and it will use GitLab to save those images. So next time when you're building it, it will use the cache, and your build time will be faster. And it will just deploy your instance in the cluster, and it will set up a host of monitoring as well. So everything. So you just need to do one request, post request, and it's done. It's easy. So that is what was Grove. For the roadmap, Grove is in active development right now. So we are still making changes, and we are targeting to be production ready by the network release, which is, I guess, in a couple of months. A few of the features that we have planned right now are support for periodic builds, so that we can do builds regularly based on changes in the OpenEDX platform. Support for custom maintenance pages, support for ingress of the few services which Grove sets up, like monitoring services and all, and more features will follow. So that is what. One thing I forgot to mention was for the mass deployments, you can set up the triggers with webhooks, and so whenever you push a change, you don't have to worry about it. It'll just do all the deployments in all the. So I guess that was all. If you have any questions. Yep.
So it sounds like Grove is reliant on a lot of like pipelines and integrations and things set up in the Git repository. Are those pipelines automatically created when you fork the repo?
The pipelines are not created when you fork the repo. The pipelines are created when you do the deployment request. So that's the call request the post request that I showed you. So it could be one of 3 or 4 kinds of requests. It could be a request to do a new deployment, deployment of a new instance. It could be changing some configuration for an existing instance. And that it detects automatically whether the instance is there or not. Or it could be a mass deployment. Suppose you have a patch in your code base, you can do a mass deployment for all the requests. So when Grove gets this request, it will trigger a default pipeline, and as part of that, it generates child pipelines based upon what. Yeah.
Can you go into more detail on how Grove interacts with Tutor?
So Grove uses Tutor for deployment. So what it will do is, so it basically it's a layer over Tutor. It uses Tutor's commands, CLI commands, to build the images. So it will supply the if you have a custom code base, it will add that supply to them, and so it will build the image, and it will do a deployment using Tutor. So Tutor is basically at the heart of Grove. Yeah. Yeah. Anything else? Thank you. Yeah. All right, thank you very much.